Welcome to a new episode of Scientific Smart Coaching, a smart modern conceptual approach for ISCE CBSC from course exam.
Welcome back to a new episode of Scientific Smart Coaching. We are now discussing over a series of periodic table, periodic properties and variation, that is chemistry chapter number 1 for class 10. And here we are discussing this in a series. The previous day we have discussed some of the elementary idea of what is elements and how does these elements are being classified throughout the ages. At first we have some knowledge about the fundamental ideas of classification of these elements by Devernier, Newlands, Mendeleev. Let us now start today's discussion, and today's topics is the more experiment that was done, that will be reflected today, that will be discussed today. And I have a small request to just subscribe my channel and share, as well as give like to this video. Actually, Mendeleev placed 63 elements known at that time, and he has some vertical column like this. These are he called these as groups, and horizontal columns like this. These are the periods. But there are some drawbacks, as we know, that this method could not explain the position of certain elements, that is, more precisely we can call rare earth elements. From this drawback, the defects were then the scientists actually tried their best to resolve this defect. And as first, scientist Henry Moseley, he actually given some clue which actually ends in modern periodic table. Moseley stated the physical and chemical properties of element are periodic function of their atomic number, not the atomic masses. That is that it is periodic, that is the physical and chemical property. Physical and chemical property actually functions of atomic number. Later, this was more elongated and more experiment was done, and then Niels Bohr give the extended form of the table that we have just known, that is the modern periodic table. The tabular arrangement of elements in group and periods signified the regular trends in property of element is called the periodic table. So what is this periodic table? It is actually a tabular form of group and periods, and it actually shows or highlights the regular trends of properties. So groups. In modern periodic table, there are 18 numbers of groups. In same group, what happens? Same group, what happens? The number of electrons in the outermost cell is same. The number of electrons in the outermost cell are same. Let us explain this one. As for example, in group 1A, there are elements like hydrogen, lithium, sodium, potassium, calcium. Hydrogen atomic number is 1, lithium atomic number is 3, sodium atomic number is 11, potassium atomic number is 19, then rubidium, not calcium, rubidium, and so on. Let's try to explain this funda, that is the number of electrons in the outermost solar cell. As we know, the atomic number, from atomic number we can get the electronic configuration, and it actually calculated in the following formula: 2n square. What is 2n square? It is the number of cell from the center or nucleus. So lithium, there is 3. So the first cell, that is this is the nucleus, and this is the first cell. The maximum number should be 2n square, that is 2 into 1 square, that is 2. So in the first cell, that is 2 is the electron, number of electron in the first cell, and in the next cell there is 1. So 2 1. In sodium, what we get? So 2 in the next cell, that is n equal to 2, where what will happen? 2 into 2 square equal to 2 into 4 equal to 8. So 2 8, and 8 plus 2 is to 10, and there is 11 electrons of 1. So look here, there in the outermost cell there is 1 electron in lithium, in the outermost cell there is 1 electron in sodium. Now for potassium, that is 19. So 2 8, number 3, so 2 into 3 square equal to 2 into 9 equal to 18 here. So 18 in potassium, that is K. 8 2 10, again 8 here should be 1, and 1 should be here. So 2 8 8 1. So in this way we now can see that the outermost cell in a same group is same. So in the groups are from left to right, and the atomic number increases. Here the atomic number actually increases from left to right. As for example, group 1A. In group 1 there is hydrogen, lithium. In group 2 there is beryllium. Lithium there is electron is 3. In beryllium electron is 4. In this way the atomic number is increases. Now group 1, it is known as alkali metal. All the elements are known as alkali metal except hydrogen. Why it is called alkali metal? Because there is a tendency, or there is the reaction, when these elements reacts with water, it gives alkali. As for example, sodium plus H2 equal to NaOH, sodium hydroxide alkali. All the elements forms alkali, so they are called the alkali metals. Group 2, they are the alkaline earth metal. Group 3 are the transition metal, have the transition metal. Group 3 to 13, actually not group 3 to 12 are all the transition metal. Group 1-3, boron family. Group 1-4, carbon family. Group 1-5, nitrogen family. Group 1-6, oxygen family. As chalcogen, they are known as chalcogens. Group 1-7, they are halogens. Group 1-8, they are the zero group. So these are the fundamentals, idea of the groups. The outermost shell of the elements of the transition elements 1 to 17 have 1, 2, 3, 4, 5, 6, 7 electrons in the outermost cells. These are known as the main group. So 1, 2, 13, 14, 15, 16 and 17 have the main, are called the main group or representative elements of the normal elements. So these are the fundamentals or basic idea of groups and the classifications of the elements in these groups. So 18 groups are there and they are classified or being named as we have discussed. So no more for today. Let's hope this discussion can grow a concept in your mind to cope with the different types of questions that arises in the ISCE board exam, that will come in the ISCE board exam. So just I have once again a small request to share this video to help your friends and others. So good night.